let's talk about the lowest common ancestor of a binary tree. So you're given a binary tree and then you want to find out the lowest common ancestor. So here's the simple example. So this is a tree and then you are given a root and then you need to have what P and Q for the target. So 5 and 1 is actually the children of 3, right? So you want to find the ancestor, which is 3, but it has to be the lowest one. So imagine like this is 5 and 1 and then there's a 7 will connect with the 3 and you still have to return 3 because 5 and 1 is the children of the 3 and then they actually find it, right? So this is pretty much the idea. So again, what if just for example, like PQ, right? 5 and 4, right? 5 and 4, right? So the root is 3, right? So you traverse the left and traverse the right, and then to see if you have it or not. Then you don't have it, then you traverse on the left, right? And then 5, okay, 5 you do have it, but how about the 4, right? So you want to traverse the left and right, and then to see, okay, now you find it, and then what is the lowest ancestor, which is 5 itself, right? So you return 5. So the algorithm looks pretty simple. So just using a recursion solution. So I'm just going to code it, and then you'll be able to follow along. So if the root is actually equal to null, right? I'm going to return null, right? Alright. So I need to traverse my left using the recursion. So I'm gonna see if I have my root, which is equal to the P and Q, right? So root of left P Q, comma, right equal to root of right P Q, right? So if I find it, so if root is actually equal to P or root is actually equal to Q, right? Which means I find it, right? So I will return root. So this is my ancestor, right? For either left or right, right? So just think about this, right? 5 and 1, right? I'm actually at 3 right over here. So 3 does not equal to P, does not equal to Q, right? So I traverse for the left and right. So root of left is actually equal to 5. Root of right is actually equal to 1. So I will return what? The root. So which is what? Which is 5 and 1. Just 5 and 1 for the left and then right? But the problem is what? If the left is actually equal to null, if the left is actually equal to null, you do something, right? And then if the right is actually equal to null, you do another thing. And then everything else, which means left and right are not a null, right? Just for example, in this case, 5 and 1 is the children of 3, right? And then I already find it, right? I already returned 5 and 1 for this, right? So the parent, the ancestor parent should be root. Alright, so what happens if the left and right are the null? So for example, this one. So I traverse from the 3, right? P and Q is actually 5 and 4, right? So I'm passing the root of left and root of right. So again, for the root of right, you will just recursively call this children, and then you will actually return null because you cannot find it, right? So okay, so when you cannot find it, the right is actually equal to null, and then the left is actually equal to 5, right? Because you find it, right? So you'll return the root, which is 5. So in this case, left is 5, and then right is null. So in this case, I know my right side is null, and then everything else should be on the left, right? Everything else should be on the left, so you'll return left. And then you should be return the first one you find. So imagine the P is not 5, P is actually 2. P is actually 2, right? So you just keep traversing on the left and right? So this is null, right? The right is null. Right, so let me do this again. Right is null. And then the left 5 does not equal to 2, right? So I will traverse the left and right again. And then now I find that this one is what? this one is actually equal to the P, right? So I will just say, okay, this is P, and I will traverse for 4, right? So this is the idea, right? So you have to find the lowest ancestor, right? So if left is null, then you will just return right. And this is pretty much the idea. So what happened? Oh yes, sorry. So here it is. Alright, submit. Alright, so let's talk about the time and space. The space is this one, and this is actually like what? Constant, right? Space is constant. And then for the time, you do have to traverse every single one of the nodes to see if you have P or Q inside the tree. Then you return what? Then you return true, I mean the root or no, right? So for the time is all open, for the space is constant. And again, what if the node is not inside the tree? So again, so for this one, this is actually really simple. When I traverse the left and right, and my right return no, right? And my left return 5, right? And then in this case, I already know my 4 is underneath of 5. Yes, it's underneath of 5, right? So I don't have to keep traversing for the rest of it. So if you look at the code, you will be able to understand. I don't have to because I already returned 5 in this case, right? So I don't have to traverse, and I know for the tree node 4 is actually underneath of my tree node 5. So I will return right away. So in this one, this is okay. But what if you have a P? So P is actually equal to 5, right? Q is actually equal to 1. What happens if there is like 9 over here, and then you don't have a P inside the tree? Then you will get an error, right? P is not in the tree. So if you want to traverse a tree, which does not exist either or P or Q, this question will be even harder. So in this case, this is considered median. So I'm not going to talk about how you solve it because I am not 100% sure. The only thing you have to know is you either check does a tree node, does P and Q exist in the tree first, then you traverse for the ancestor later. So this is my first approach, but I might be wrong, but whatever, right? This is not the question related, but this is the thing you have to think about. What if the tree node is not in the tree, right? Alright, so for this question solution, this is pretty simple, and I'll see you next time. Bye.